All right, so good evening, everyone, and feels good to be back after a long time. So we'll be discussing the bi-weekly contest for today. So the contest number was 122, bi-weekly contest 122. The date when I'm recording this video is 20th January 2024, and the time is 11:20. So let's get started with the contest. So just as usual, as we say that I'll give a brief summary of the contest. I would say it was again a fairly simple contest. The first two problems were very easy. The third problem was an observation based problem. So I didn't really like that problem, but then again, it's a contest, so you just have to solve this problem somehow. So, yeah, the code for it was pretty simple, but then again, it was more towards observation. The last one was a fairly difficult problem. So, yeah, I think the first three problems could have been solved in around 40 to 45 minutes. So, yeah, that was easy. Now let's go through the problem statements one by one. Okay, and I'll show the solution and we'll discuss the approach on the whiteboard as well. Okay, so the first problem for the contest is where is it? Wait a minute. Okay, I'll have to open this. Just give me a minute. Okay, let's start our whiteboard also till that time. Okay. So, what we are discussing today is, oops, I did delete both. Wow. So, this is LeetCode bi-weekly 122. Alright, let's get started with the discussions. So, we are given an array of integers of length n. The cost of an array is the value of its first element. Okay. So, for example, if we take an array, so the cost for that will be 1 because 1 is the first element. Okay. So, we need to divide our nums array into three disjoint contiguous subarrays, and we need to return the minimum possible sum of the cost of these subarrays. Okay, and the constraints, if you see, are very small. So because the constraints are very small, we can go for a n cube solution for this question. Okay, there are better solutions for this, but because we are in a contest, so and the constraints permit us to solve this question in n cube, so we can go for an n cube solution. Okay, let's see. I think I coded it somewhere. Let's just let me move to that problem page. Hmm, yeah, here is it. Okay, here it is. Okay, let's firstly see how to solve this. Okay, so the cost of the array has been given to us as the first element. So it's very simple. We can run a for loop. Okay, because for the first subarray, we need to divide a given array into three subarrays. Okay, so for the first subarray, the answer will always be the zeroth element. Okay, because that is how you will start anyways. It doesn't matter what how many elements you take, but the first array will have the zeroth element as its answer. Okay, so let me move on to a new page now. Okay, so from this array, okay, I'll take a some variable, let's say, let's not take it. In fact, take an answer variable, initialize it to int max because we need to take the maximum value. I run a for loop starting from 0 till n minus 2. Why n minus 2 I have taken? Okay, because we need to take three subarrays and all none of them can be an empty one. So if I take the first n minus 2 elements in the first subarray, so I'll have to take two subarrays out of the second last and the last element. So that is why my limit here would be n minus 2. Okay. So yeah, I signifies the ending point of the first subarray. Okay, because for the first subarray, I know that the starting point is the zeroth element. I am taking the case starting from zero because I'm taking the case when there's only one element in the first subarray. Then I'm taking when two, then three, then four. This is how we'll be going. Okay, so this is our first loop. Then we'll have our second loop. j which will start from I plus 1, and this will go till n minus 1. Okay. And after that, we'll have k which will start from j plus 1, and this will go till n, the very last index. Okay. And I just update my answer every time as min value of answer, comma. Let's say nums is our array. So nums 0, because 0 element would be taken every time. Then nums j and nums of k. Okay. So I've taken all these elements and you just return the answer after coming out of these loops. So that's it. And the complexity for this code would be O of n cube because we are running three nested for loops. Okay. So n cube and O of 1 as the space complexity. Now let's see the code for this quickly. This was the easiest problem as usual. So I hope everyone would have solved this question. Okay, so I'm initializing my sum variable. N is the size. I go till n minus 2, then n minus 1, then n, and I update my sum variable every time with 0, jth index, and the kth value. Okay, and I just return the sum variable. Simple as that. If you just run it, it will get submitted. Okay, so this is how the first problem goes. Let's move on to the next problem quickly. Okay, the next problem is find if an array can be sorted. So we have been given a zero index array of four positive integers nums. In one operation, you can swap any two adjacent elements if they have the same number of set bits. Okay, so you need to be aware of bit masking a bit of bit masking to solve this question. Just to know okay, how to count the number of bits in a number, how to count the number of set bits in a number. Pardon me. So you are allowed to do this operation any number of times, including 0. Okay. Return true if you can sort the array, else return false. Okay. Simple as that. So we have been given an operation that we can swap the elements which have the same number of set bits, and after any number of swappings, we just want to know whether the array is sorted or not, whether we can get a sorted array or not. Okay. So the most important observation for this question would have been, oh, just let's see. Yeah. So we have problem two. Okay. The most important observation is that you have groups of numbers. Let's say we have six numbers. Okay. Six numbers. This number has four set bits. This has two. This has two. This has three, four, and one. Okay. So if you see, I can make groups of these numbers like this. Okay. Four and four. 2 and 2 is a separate group, okay, and 3 is itself a separate group, and 1 is itself a separate group. So we have four groups here. This is how we can swap elements. So if let's say there are 100 more elements having four set bits, so this group would have been 102 elements, and what would have been the case that I can swap these 102 elements anyways, the way I like. It's up to me. It doesn't matter how many operations I take. Okay, this is what I have been given. So this is how I'll have to group these elements. Okay. After grouping these elements, can I say that if there are elements in a group, so I can individually sort that group. Okay. Let's say if there is six here and there is three here. So I can sort these two, of course. I can make a swap operation and I can do three and six. And if there would have been, let's say, some 100 more elements. Okay. 100 more elements. So I could have sorted them as well. So these 102 elements, these are sorted in themselves, okay, not in the complete array, but themselves, these 102 elements would have been sorted, okay. So this is what is a very important observation for this question that we need to have groups of elements. So after the groupings are done, okay, what do I need to do? I need to take the elements in that original order only, and I need to check if the array is sorted now. Okay, let's see the code for this first. Okay, then we'll get some better idea. Okay, just a minute. Okay, so this is the base case that firstly I'll be checking okay, if the array is already sorted, then why do we need to do any operations? So I can simply return true. Okay. Next, what you need to do is based on the number of set bits. Okay, you are grouping the elements and storing them in a map data structure. Okay, map integer comma vector integer. So this is how I am storing the elements. Then what I'm doing? Wait a minute. Wait a minute. I think this is the old code. Just give me a minute. Yeah, this is the new code. Sorry. That was the old code which I had written. Sorry. Yeah, let's see this. Wait a minute. So we are done with the first. Yeah, this is the second problem. Okay. Although it's again the same thing. Okay. I'm not using a map this time. I made some mistake while solving. So, yeah, we have a count vector and we have a copy vector. Okay. What I'm doing is for every element, I'm firstly counting the number of set bits. Okay. Then I'm pushing the number of bits, the number of count of a particular number of set, the count of the set bits of a particular element into this count vector. Okay. This temp variable is storing the count of set bits. Okay. Now this part is done. Now what I'll be doing is I need to check whether the original order can be maintained or not. Okay. How do I check it? Okay. Take the consider this case what they had said in the question, that we can swap any two adjacent elements if they have the same number of set bits. Number the two adjacent elements. We cannot swap any elements. We can only swap the adjacent elements. Okay. So adjacent elements is a very important point which comes into picture now, because it could be a possibility that you just don't read this and you just take those 100 elements as I said and you sort them individually. No, we cannot do that because we only can swap the adjacent elements. Okay. So what we'll be doing here is that for every element, let's say I had already stored the count now. Okay. So let's say if there are four consecutive elements with the same number of set bits, I can sort them now because first point they are consecutive and the next point is that they have the same number of bits. So we need to have both these conditions satisfied. Okay. Then only we can sort it. So let's say I start a for loop here. Okay. We have a start variable and we have an end pointer here. Okay. Then I run a nested for loop here. Okay. I run a nested for loop and I just check for consecutive elements if the count of the jth element is same as the ith element. We have the ith variable as the fixed one. So I'll check the consecutive elements, the elements which are having the same values. Okay. The ones which are having the same values, I'll push them to my copy vector. Okay. Copy vector which we had created initially, this is still empty. Okay. So I'll just push the element every time and I'll update my end pointer. Why I am doing this, we'll discuss that just briefly. Now let's come to a case when we come at an index j when these values are not equal. So till the when we come to such an index, that means we cannot do any sorting operations now. So we need to break the loop because that jth index is the till j minus 1 only we could have done that operation which has been given to us in the question. So we break out of the loop and I update my start pointer. Okay. I update my I variable because you see I have not given any increment here till now. Okay. I update this with the end pointer. Okay. Because let's say till it went from I till j minus 1. So at jth point it breaks out of the loop. Okay. Now for the next element, I need to start from the jth element. Okay. So I need to store that value and I need to sort these values as well, which I have just inserted. So I'll sort the values from copy.begin plus start till copy.begin plus end. Okay. Now let's move on to the whiteboard now, just to understand how this all of this is working. Okay. So I firstly we store the counts of all of the values, the number of set bits. Okay. The counts vector. This is what we are maintaining. Okay. This stores the number of set bits for each element. Okay. Now, what I'm doing is let's start iterating with our this counts array. Okay. So let's say I is at this point. Okay. At initially it's at 0. Okay. I keep on iterating. Let's say I reach some index j. Okay. This is the last index. Okay, which has the same number of set bits as the ith element. So all the elements between j to I, they have same set bits. Okay. So I can perform my swapping operation on them. Okay. So what I'll do is I'll push all of them in my copy vector. Copy vector till now it was empty. Now it has all the elements from I till j. and I can sort these elements. Okay, I can sort because I can apply the operation which has been given. That is why if you see I am doing in my code copy dot begin plus start plus end, because we need to maintain what from what index till which index we need to sort the array. Okay, we cannot do the sorting every time from the zeroth index. Okay, so this is how it's going. Okay, next what is happening is now my start pointer gets updated. I gets updated from end. Okay. Now let's say we go till another index, say j again. Okay. This again is another subarray with same set bits. Okay. And I'll push it again. So this is I1. I'll name it I1 till J1. Now I need to sort this. Okay. I'm not sorting the complete, I'll take a different color this time. I'm not sorting this complete subarray. I'm just sorting this subarray this time. This is sorted, okay, but we are not sure whether these two are sorted in themselves together or not. Okay, this is what we'll have to check. So by doing this operation, we'll have all the elements in our copy vector. Okay, it'll be like some sorted subarrays. Okay, some operation like this. Now what I'll do is I'll sort my initial nums vector which has been given to us. Okay, so I'll sort it and I'll just check if copy is equals to sort. If this is true, copy is equals to num, sorry. If this is true, if this condition holds, then we return true, else false. Simple as that. Because that is what we need to check. Okay, after applying all the swapping operations, are we able to sort our array or not? So this is what we need to check. Okay. So yeah, we have checked that. Okay. Now coming on to the time complexity of my code, although this seems like a n square solution, but it's not. Okay. In this part, we are just checking the number of set bits. So this part will have O of n complexity. This is O of n. Okay. No, not like this. We write it like this. Okay. This is O of n, because worst case possibility this will be 9 bits, sorry, 8 bits, because they have given the value of num psi to be between 1 to 2 power 8. Even if the case would have been that this is 2 power 31, then also this loop would have had a worst case complexity of o power o 31. So this is again constant. Okay, so yeah, sorry, let me just add a comment like this now. Okay. And this part, this is very important to notice. This seems like an n square, but if you see, I am only iterating over n elements. Okay, I go from some index, let's say I till j. Then I start from j plus 1 till some index k plus 1, let's say, and I reach till n minus 1. So I'm not reiterating over any element. Okay, that is why this complete n square kind of a what do you call it, this nested for loop would still have a complexity of O of n. Okay, this is again O of n. The sorting operation is O of n log n. Okay, this is the worst case complexity of our code. So the worst case complexity therefore becomes n log n because of the sorting operation. So yeah, the complexity becomes n log n. Okay, yes. Okay, so let's try and submit this. Okay. If you submit this, this will get submitted. Okay, you can check it on the row. We want to finish the video today quickly. So, yeah, coming on to the third problem. This was kind of a good problem, but I don't personally like these kind of problems because this is more for observation rather than logic. Okay, excuse me. So, let's go through the problem statement. We have been given a zero index integer array nums containing positive integers. Our task is to determine the length of nums by performing the following operation any number of times. Okay, select two distinct indices I and j from nums such that nums of I is greater than 0 and nums of j is greater than 0. Okay, so we can select any two elements which are greater than 0 and insert the result of nums of I modulus nums of j at the end of nums. Okay, so we do this operation, modulo operation, for both of them, and we insert the result at the end of the vector or the array, and we delete the elements at indices I and j. Okay, so this is interesting that we are removing those two elements and we are putting their result at the end of the vector or the array. Okay, now the observation for this question is that wait a minute, let's move on to the next thing. Yeah, if I have some distinct elements, okay, let's say I have elements A, B, C, D, E. They have some distinct values, okay, all of them, okay, and let's say these are already sorted. That is, A is the smallest, B comes after that, C, then D, then E. So I can, after performing this operation, which has been given to us, I can reduce this thing into a single element. Okay, how I'm doing that? Because let's say if I firstly take A and E, okay, and I do A as my I and E as my jth. So I'll do A modulus E because E is greater, so this would return A, and I'll delete those two values and I'll have a A in place. Okay. Now let's take D and A this time. So again I'll do the same operation. I'll delete one D, one A, and I'll get one A again. Same operation for C and A. C and A get deleted, I get another A. Then B and A deleted, I get A. So this can be reduced down to a single A element. Okay, this was a very strong observation for this question. Okay, next what we need to check is that uh, let's say for any element, okay, if there is I just sort this complete array, okay, if I just sort it and let's say I take the minimum element, okay, nums of 0, let's say this is represented by x, okay, if I take x out of my complete array, okay, now you would say, sir, by if we go by this observation, then we can always get only one element. No, that is not the case every time. Okay, it can be a possible case, but it is not always true. How we'll get to know this quickly. Okay. Another observation for this is that let's say some element y exists. Okay, and y modulus y modulus x is not equals to 0. Okay, then I can get 1 as my final smallest size. Okay, you can take an example for that. This is, as I said, this is more of an observation based problem. So you'll have to do the observations on your own. You have to run examples. Okay. If I take, let's say, let's take some examples because I think I made a mistake in this question. So let me check my submissions. Yeah. Okay. I made a mistake myself in this question initially. So if I take the first case, okay, this was the case which gave me the better idea. Okay. 2, 2, 2, 5, 9, 10. Okay. So what I thought was that what I can do is I can remove these 9, 10, 5, and 2. Okay. Because 2 and 5 do the operation, you will get 2. 2 and 9 do the operation, you will get 2. 2 and 10 do the operation, you will get 2. So at the end, you will have 3 twos. And out of 3 twos, you can make 2 elements in worst case. No, this is not how we do it. Okay. Another observation which we are missing here is that if there is any element for which y modulus x is greater than 0, okay, let's move on to the whiteboard again. Okay, as I said, if there is any element y for which y modulus x, which is our zeroth smallest element, if this value is not equals to 0, then I can take their remainder. Okay, I will take their remainder. Okay, this is y modulus x, and by this remainder I can remove all other values of the array except x. Okay, except x. So at the end, what would happen is that I'll have two values, that is remainder and x. Okay, you'll have these two values, and again you do a one operation on this and you'll get a single element at the end. Okay, so yeah, this is what I was talking, that for if any for any element, if this condition exists, for the x is the smallest element and for any element y modulus x is not equals to 0, so you'll always get 1 as the smallest size of the array. Now let's come on to the other case, that is all the elements are divisible, okay, by the smallest element. That is the case, let's say when we have 1, okay, we have 1 to 1 4 times, and then let's say we have 4 3, and 2. Okay, this is some kind. So I can remove, again, these are four distinct elements. Okay, so I can remove them into a single one. Now, if you see all these elements, 4, 3, 2 are divisible by 1. So we cannot get the remainder case. We'll get a 0 in every case. And if you read the question, if you get a 0, you cannot replace the 0. So we want to avoid getting any zeros. Okay, only in the worst case scenario, we'll try to get a 0 because they have said for performing an operation, the elements should be greater than 0. So you cannot perform any operation with the 0th element. So we want to avoid this 0 condition. Okay, that is why we are doing such a case. Okay, so we just reduce this and we get 1. Now you cannot do anything out of it. You have 4 ones. Okay, from this 4 ones, you will just return the ceiling of this value. Count is the count of ones, and you will return the ceiling of this. Okay, ceiling function. I hope all of you are aware of the ceiling function. Okay, so this will be your answer. Again, this is more of an observation based question. So you'll have to make some observations, do some mathematics on your own. The complexity for this code is O of n because we are iterating over the array to check if any element has y modulus x greater than 0. Okay, so just for that case, we are taking this. Okay, O of n complexity. So yeah, this is how you run it, and when you submit it, it will get accepted. Okay, simple as that. So these are the first three problems. Now coming on to the last problem. This is a good problem again. But yeah, again, for the last problem, as I always say, a lot of things would depend on how much practice you have done. It's not always about whether it's difficult or not. Because when you come out of the contest and when you see the editorials, the videos, you'll always feel that this was an easy problem. But a lot of it depends on how much practice you have done so that you can think that you have the same perspective during the contest that okay, this is an easy problem, this can be solved in the contest duration itself. Okay, so yeah, we have been given a zero index array of integer nums of length n and two positive integers n and k. Here I'm recording. Yeah, k and dist. Okay, the cost of an array is the value of the first element. For example, again, this is something which is similar as the first question. Let's see what is different in this question. You need to divide nums into k disjoint contiguous subarrays such that the difference between the starting index of the second subarray and the starting index of the kth subarray should be less than or equal to dist. Okay, so we have been given a variable k that we want to divide our array into k contiguous subarrays and a variable dist. Okay, which means that the difference between the indices of the second and the last, okay, that is the kth subarray, should be less than or equal to this distance value. Okay, so and what we want to return, we need to return the minimum possible sum of the cost of these subarrays. Okay, so we need to return the minimum possible cost, so we need to take into consideration that the second and the kth one have a difference in their starting indices less than or equal to k, less than or equal to distance, and also the sum of the cost of these k subarrays is the minimum possible. Okay, this is what we need to store. All right. Let's see an example. 1, 2, 1, 3, 2, 6, 4, 2. K3, dist 3. Okay. So we divide it into 1, 3, 2, 6, 4, and 2. And this is valid if you see. You can check it on your own. So the minimum cost would be 1 plus 2 plus 2. Okay. 1 plus 2 plus 2. Okay. So for this question, if you see, as again, the very simple observation is that for the first one, the value would always be nums of 0 because that is the fixed value for the first subarray. So we need to return the answer for k. We need to find the minimum value for the k minus 1 possible subarrays. How do we do that? Let's see. Let's see. Okay. Think about this. Think about reducing this problem is that you have a subarray. Let's move on to the whiteboard. Okay. Okay. I'll be better explaining it here. Okay. So yeah, problem. Oh, okay. So we have been given this array. Zeroth is the fixed, okay? This is always taken, okay? Let's say we are taking this as the first sub-array, okay? Now from the rest, okay? What if you just boil this down, what you need to do is you need to consider k minus 1 smallest smallest values from sub-array of size distance. Okay. Subarray of size distance. Okay. Think about this that let's say if you take as the first element as the starting index of the second one. So the maximum possible index you can take for the last one is distance plus 1. Okay. Distance plus 1. This is for the kth one because they have given a condition that the difference between the second and the last one, kth one, should be the difference between them should be less than or equal to k. So the maximum possible index which you can consider if one first index is the starting of the second subarray, then the maximum index which you can take for the kth one is dist plus 1. So the subarray now becomes of size dist plus 1. Sorry, not dist, it should be dist plus 1. Okay. So this subarray would have a size of distance plus 1. Okay. So you need to consider k minus 1 smallest values from subarray of size, subarray of size dist plus 1. This is the problem and this is the most important observation in this question. Okay, this is very, very important to solve the question. Now, what we'll do every time in this case would be that zeroth always is fixed. Okay, so let's say I'll take the first subarray after this of size dist plus 1. Okay, then I'll remove one of them, then I'll take the next one, then I'll take the next one, then I'll take the next one, and this is how we'll be going on till the end. Okay, and I'll take two sets for maintaining these values, the k minus 1 smallest values. Okay, how we are going to do that, we'll see through the code. Okay, but this is the most important observation of this question. Now, for this question, we'll straight away see the code. Okay, that'll give you a much better idea. Okay, I'll take n as the size, k I have reduced because I have the answer for the first subarray. So we need to find for k minus 1. Okay, now I take the, as I said, uh, subarray of size dist plus 1. Okay, so I'll go from index 1 till dist plus 1. I'll add the elements to my current. Okay, current is currently storing the zeroth value. So I'm taking that I'm considering that I'm taking the first dist plus 1 values in my answer. Okay, the currently that is what I'm considering, and I'm adding it to the multi-set. I've taken two multi-set, one for storing the lower values and one for storing the higher values. That is the k minus 1 small values will be stored in L and the rest of them will be stored in R multi-set. Okay, so I'll insert nums of I to this. All right, this is what I've done. Now I need to just take the k minus 1 values out of it, okay, from n. So I'll remove the values from the end, okay, and I'll insert it to the R multiset. That is what I said, that is what I've told you, that I'll take the k minus 1 and I'll store them, k minus 1 smallest, and I'll store them in L and the rest will go to R. Okay, so this is how I've done that. Now this is my first answer. This can be an answer, but I'll have to, as I said, I'll have to iterate over all the subarrays like this as I have mentioned. So currently I've taken this part. Okay, all of them are left till now. So the next part of the code will cover this part. Okay, so let's go back to the code. Okay, now I'll start from dist plus 2. Okay, now I'm taking my end index every time. I'm taking that this is the starting index of the kth subarray. So I'll have to remove the values from the beginning now. Okay, so yeah, this is the starting index of my kth and I'll go till n. Now what I'll do is I'll remove the value. Which value I'll remove? I minus dist minus 1, because this value, nums I minus dist minus 1. This will now become a part of the first subarray. Okay, let's move on to the whiteboard again. Okay, if you see, as I said, if I remove this value, when I remove this value from here, so this is becoming a part of the first subarray only now, right? Because I'm taking these values, no? So this is becoming a part of the first subarray. Okay, this is what is happening here. Wait a minute, where's my mouse? Yeah. Okay. So yeah, I'll subtract it from current and I'll erase it from L. If firstly I'll check if it is present in L or not. If it is present in L, then I'll have to remove it from the current answer and I'll have to remove it from L as well. And if it is not present in L, then surely it will be present in R. So I'll remove it from R now. Okay, because we do not want to have unnecessary values. We only, in total, we only want to have dist plus one number of values in both the multisets. Okay, out of that, k minus 1 are present in L, and the rest, that is dist minus k minus 1, that number of values will be present in R. Okay, this is what is happening here. Okay, now, yeah, this is done. Now I'll add this element to my L, because yeah, this has to be added to the answer. So I'll firstly add it to answer and I'll insert it to L. And now if the case that if this is not, if this value is already greater than the this thing, the last value of L, so I'll have to insert it to R. Okay, think about this a bit. Okay, I'll have to insert it to R every time. And please make sure that at every step we'll also have to check that L only stores K minus 1. So if that is the case that the size of L is less than K, you'll have to add the answer to it. You'll have to remove the first element from R now and insert it to L and erase it from R. Similarly, if the size is greater than K, you'll have to remove it from current, insert it to R and remove it from L. And at every step, at the last, you are updating your answer variable. Okay, answer was initially storing current, so you are updating current every time, and you are taking the minimum value of answer, and you just return the answer. This is how you go about it. Now, if you submit it, it will get accepted. Okay, this is how we are going. So the complexity for this code is again n log n, because we are iterating over the array once only. Okay, and we are doing insertions and deletions from the subarray. Those not subarrays, these multisets. So the complexity for that is log of n. So if you just visualize this, this part of code will have O of n complexity, and this internal parts, all of them will have some log n kind of complexity. Okay. So the overall complexity would become n log n. Okay. And yeah, this finishes the discussion for today's contest. Let's rate the problems again as we do every time out of 5. So the first problem is 1 out of 5. Second is again 2 out of 5, let's say. Third one, I will say again, like yesterday, last Sunday's contest, it was still difficult this time and bi-weekly. So I'll rate it as 3 out of 5. Okay. And the last, fourth problem, this could be somewhere between 4 to 5 out of 5. Okay. So yeah, this finishes the discussion for bi-weekly 122. And yeah, let's meet tomorrow morning for weekly contests and we'll solve all the questions. We'll discuss approach here on the whiteboard. And till that time, happy learning, stay safe, stay healthy. Happy New Year to everyone, belated. So, yeah, good night. Bye bye.